Hey everyone, and welcome back to another lab. Again, this lab is very similar to the one where we configured a floating static route using IPv4. We will focus today on using IPv6 protocol instead. And because of this, I won't be going over the lab topology and the lab objectives or the lab tasks again. Instead, I will include a link in the video description below for those who missed that lab. From there, you can go directly to the specific topic you are interested in by using the timeline in the video. So by the end of this lab, you should be able to configure primary and floating static routes on Cisco routers using IPv6 protocol. You will also verify the operation of floating static routes using show commands and test the failover mechanism by simulating a link failure. And we will also do this by unplugging the primary interface that connects to the ISP1 router. Okay, so with that being said, this is the moment where I ask you to pause the video and try this yourself to test your knowledge and skills. So I have added the lab document in the video description so you can download it and practice at your own pace. I've also included a couple of packet tracer labs for you to download. You will find a pre-lab and a post-lab version. The pre-lab is for those who want to tackle all tasks from the beginning, while the post-lab provides the full lab solution. Okay, so I'm going to tackle the first task, and the first task is all about verifying the current configuration across all switches. So I'm going to jump into the branch 1 switch 1, and I'll go to the CLI, and from there I should be able to go to the user privilege mode by issuing the enable command, and from there I will issue the show interface status. And here we can see that fast Ethernet 01 is connected to PC1, fast Ethernet 02 is connected to PC2, and gig Ethernet 01 is connected to branch 1 router 1. All the interfaces that are connected, you can see that are part of VLAN 201, and fast Ethernet 01, fast Ethernet 02, currently they are connected, as you can see under the status information or status column. Whereas the gig Ethernet 01, the current status is not connected, and the reason being is because the other side of the link is admin down. But you can see that this interface is also part of VLAN 201. Let's quickly look at the current configuration. So I'm going to say show run pipe section 0/1, and I'm going to include the $sign. And you can see this is the current configuration under interface fast Ethernet 01 and gig Ethernet 01. If I up arrow this and change the interface ID to 0/2, you can see this is the current configuration for interface fast Ethernet 0/2, where I'm highlighted on the screen. And as you can see from the screen, the current configuration that is being assigned to each interface implies that is part of the appropriate VLAN, and also each interface is configured with mode access. Let's repeat the same thing on the branch 1 switch 2. So I'll go to my topology and I'll click on branch 1 switch 2. I'll go to CLI and I'll repeat the same thing. So I'm going to say show interfaces status. And again, fast Ethernet 01 is connected to PC3, fast Ethernet 02 is connected to PC4. Fast Ethernet 01 and fast Ethernet 02 are part of VLAN 202, as you can see on the screen, and both of them right now are connected. You can see gig Ethernet 01 is connected back to branch 1 router 1, currently is part of VLAN 202, and right now is not connected, and the reason being is because the other side is connected to an interface that is admin down. Let's quickly examine the configurations. So I'm going to say show running pipe section 0/1. I will include the pipe, and I will up arrow this, and I will also include 0/2. And what you see on the screen, this is the current configuration that is being assigned for each interface that is connected to the end devices. Now let's repeat the same thing under headquarter switch 1 and headquarter switch 2. So I'll go back quickly to my topology and I'll go to headquarter switch 1 first. And again, fast Ethernet 01 is connected to PC5, fast Ethernet 02 is connected to PC6. Both of these interfaces are part of VLAN 101, and the current status right now is saying is connected. And the gig Ethernet 01 is connected to headquarter router 1, and you can see that is part of VLAN 101. Again, the current status is not connected, but we know that the reason being is because the other side of the link is admin down. Let's quickly examine the running config. So I'm going to say show run pipe section 0/1 and also include the $sign. I'll up arrow that and I will change the 1 to 2. And here is the configuration under these interfaces that I mainly use to connect to the end devices and to connect to the headquarter router 1. Next, I'm going to jump into headquarter switch 2 and just complete this task. And again, fast Ethernet 01 is connected to antenna server 1. Fast Ethernet 02 is connected to antenna server 2. These two interfaces are part of VLAN 102. And also you can see gig Ethernet 01 that is connected to headquarter router 1 and also is part of VLAN 102. Let's quickly examine the configuration. And what you see on the screen, this is the current configuration that has been set under each interface. Next, I'm going to jump into the second task where we are going to configure basic configuration across branch 1 router 1 and headquarter router 1. So I will start with branch 1 router 1 first. So I'll go back to my topology and I'll go to branch 1 router 1. Go to the CLI, and from there I should be able to go to user privilege mode, and from here I can go to global config mode. And then what I'm going to tackle first is the interface that connects to branch 1 switch 1. So I'm going to say interface gig Ethernet 0/1. I will set the description quickly where I'm going to say link to branch 1 underscore switch 1. And next, I'm going to actually enable the IPv6 services by saying IPv6 enable. And then I'm going to say IPv6 address. And then I would say 2024 colon 2001 colon 10. And the subnet mask is going to be 64. I will need to enable the interface. So I'm going to say no shutdown. And the first interface has been configured. I'm going to configure the second interface that is connected to branch 1 switch 2. So I'm going to up arrow that multiple times, and I will change this to interface gig Ethernet 0/0. I will then set the description. So I'm going to say description link to branch 1 switch 2. Again, I will enable IPv6, and then I should actually say IPv6 address, and I'm going to say 2024 colon 2002 colon 10, and the subnet mask is going to be /64. I would need to enable that, so I'm going to say no shot. Next, I'm going to tackle the interface that is connected to headquarter router 1. So I'm going to say interface gig Ethernet 0/0/0. I'll set the description to link to HQ underscore router 1 or R1. I will enable IPv6 services, and then I'm going to set IPv6 address with 2024 colon 2000 colon 1000 colon 2, and the subnet mask is going to be 126. I will enable the interface by saying no shot, and then I'm going to hit end. And now let's perform some in-flight checks. So I'm going to say show IPv6 interface brief. And right now you can see that we have configured 3 interfaces, gig Ethernet 00 with the IPv6 address of 2024 colon 2002 colon 10. And the second interface that we've configured has an IP address of 2024 colon 2001 colon 10. And you can see both of these interfaces are in the up state. And then the third interface that we've configured is the gig Ethernet 0/0/0, which is connected back to the headquarter router 1. You can see this is the IPv6 address that we have assigned under that interface, which is 2024 colon 2000 colon 1000 colon 2. The status of this interface currently is down, and as I mentioned earlier, the reason being is because the other side of the link is admin down. Next, let's reveal the IPv6 routing table. So I'm going to say show IPv6 route, and you can see that these are the 3 networks that we have configured are already being populated under the IPv6 routing table. Let's look at the running configuration. So I'm going to say show run -config, and I'm going to say section 0/0, and I'm going to include the $sign. And you can see that this is the configuration that we have implemented under the gig Ethernet 0/0, which is connected to branch 1 switch 2. If I up arrow this and change the interface ID from 0/0 to 0/1, we get the configuration under this interface gig Ethernet 0/1, which is connected to branch 1 switch 1. So one other thing that we need to do is we need to configure the IPv6 unicast routing to allow external communication. So I'm going to go back to global config, and from here I would say IPv6 unicast routing, and then I would hit end, and let's just perform some in-flight checks. So I'm going to say show running section unicast, and you can see that the command has been taken under the running config, as you can see on the screen. Next, I'm going to jump into PC1 and perform some local connectivity. I'm going to make sure that PC1 is able to reach PC2 and PC3 as well as PC4. So I'll go back to my topology quickly, and I'll go to PC1, and then I'll go to command prompt. First of all, I'm going to just issue the ipconfig command, and you can see this is the IPv6 address that has been assigned to the PC1 interface, and this is the default gateway. So what I'll do, I will issue the ping command to 2024 colon 2002 colon 3, and this is the IPv6 address for PC3, by the way. And you can see that I'm able to reach PC3. So if I up arrow this and try to reach the default gateway, which is 2024 colon 2001 colon 10, I should be able to reach it. And as you can see on the screen, we have reachability and connectivity. That means I should be able to reach also PC2. And for completeness sake, I am also gonna try to reach PC4. So I'm gonna up arrow multiple times to get to this command, ping 2024 colon 2002 colon 4. And we have reachability and connectivity within branch 1 side. Next, we're gonna jump into the headquarter router 1 and perform some basic configuration in there. So I will go back to my topology, and I will jump into headquarter router 1 stencil, and from there I'll go to user privilege mode and then go to global config, and I'm gonna tackle the interface gig Ethernet 0/1, which is connected to the headquarter switch 1. So I'm gonna say description link to HQ_SW1. Let's enable IPv6. And I'm going to set the IPv6 address under that interface with 2024 or 2024 colon 1001 colon 10, and the subnet mask is going to be /64. I will also enable the interface, so I'm going to say no shutdown, and then I'm going to tackle the second interface that is connected to headquarter switch 2. So I'm going to say interface gig Ethernet 0/0, and then I will set the description with link to headquarter switch 2. I will enable IPv6 services, and then I will set the IPv6 address to 2024 colon 1002 colon 10/64. I will also enable the interface. So with that being done, we can jump into the next interface that is connected to branch 1 router 1. So I'm going to say interface gig Ethernet 0/0/0. I'll set the description, and I'm going to say link to branch 1 underscore router 1. Let's enable IPv6 and assign IPv6 address under this interface. So the IPv6 address is going to be 2024 colon 2000 colon 1000 colon 1 126. Let's enable that interface. I'm going to say no shot. You can see the interface went up. Next, let's tackle the primary interface where it's connected to ISP1. So I'm going to say interface gig Ethernet 0/1/0, and I'm going to set the description, link to ISP1. I'm going to enable IPv6 services, and I'm going to assign IPv6 address, and I'm going to say 2025:2024:1/126. I'm going to enable this interface. I will up arrow this multiple times, and I'll change the interface ID to interface gig Ethernet 0/2/0. I'm going to set the description to link to ISP2. I will enable IPv6, and I will set the IPv6 address with 2024 and then :2023:1/126. Let's enable the interface. And then one other thing that we need to do before we actually exit the global configuration is we need to configure IPv6 unicast routing. So next, let's perform some in-flight checks. So I'm gonna say show IPv6 interface brief, and you can see that we have configured 5 different interfaces with 5 different IPv6 addresses. So I'm not going to go through these with you again, but you can see that this is the IPv6 that is being assigned under this interface. The current status is up. And this is the second interface, which is gig Ethernet 0/1, that is connected to headquarter switch 1 and has this IPv6 address. The current status is up. And then the third interface is gig Ethernet 0/0/0 that is connected to branch 1 router 1. The current status is up. And this is the IPv6 address. And then this is the interface that connects to ISP1. The current status is up, and this is the IPv6 address that is being assigned under this interface. And finally, the interface that is connected to ISP2 is also up, and this is the current IPv6 address. Let's quickly look at the IPv6 routing table. So I'm going to say show IPv6 route. Again, all the different interfaces that we have configured, you will be able to see them here. And then next, I'm going to look at the current configuration. So I'm going to actually say show run, and I'll just hit the space button. And you can see this is the configuration under interface gig Ethernet 0/0. This is what we've configured under this interface. The same applies here and there as well. What I will do next, I will perform some local connectivity between PC5 and PC6, as well as internal server 1 and internal server 2, as well as the default gateway. So I'm going to exit this, and I'll go back to my topology, and I will go to PC5, and then from there I'll go to command prompt. And what I'll do, I will try to ping PC6. So I'm going to say ping 2024:1001:6. You can see that I have reachability and connectivity between PC5 and PC6. So if I up arrow this and try to ping the default gateway, you can see that I also have reachability to the default gateway. And if I try to ping internal server 1, so I'm going to say ping 2024:1002:101. You can see that I am able to ping internal server 1. Let's ping internal server 2. And you can see that we have reachability and connectivity to internal server 2 as well. So what I'm going to do next, I'm going to jump into branch 1 router 1 and configure a default static route for unknown or external networks, with the next hop address set to the headquarter router 1 IPv6 IP address. So I'll go back to the branch 1 router 1, and I'll go to configure terminal, and I will issue the IPv6 command. I'm going to say IPv6 root. I'm going to say :/0, and then I will set the next hop address to the headquarter router 1 IPv6 address with 2024 colon 2000 colon 1000 colon 1. I'm going to hit end, and let's just verify our configuration. So I'm going to say show IPv6 root, and you can see that this is the default static root that has been implemented, and you can see this is the next hop IPv6 address. Next, I'm going to jump into step number 5, where we need to go back to headquarter router 1 and configure a static root for each network that lives or resides in the branch site office. So I will go back to headquarter router 1. I will then go to global config, and I will say IPv6 root 2024 colon 2001 colon /64, and the next hop address is going to be 2024 colon 2000 colon 1000 colon 2. I will up arrow this and change the IPv6 destination address to 2002, and I will hit end. Next, let's verify that the static root has been implemented in the routing table. So I'm going to say show IPv6 root. And sure enough, you can see that these two IPv6 networks have been implemented in the routing table. So now what we're going to do, we're going to jump into step 6, where we are going to configure a default root with the next hop address set to the ISP1. So I'll go back to global config, and I'll say IPv6 root. I'm going to say :/0, and I'm going to set the next hop address to the ISP1 IPv6 address. So it's going to be 2025 2024 2. I'm going to hit end, and let's just quickly verify our configuration. So I'm going to say show IPv6 root. Okay, for some reason I can't find the static root being implemented in the routing table, which means I have mistyped the configuration somehow. So what I'm going to do, I'm going to look at the configuration under the interface that is connected to ISP1. So I'm going to say show run section interface, or actually I'm going to include the interface ID, which is 0/1/0. I'm going to set the $sign as well. And I can see that I have mistyped the IPv6 address here. So what I'll do, I'll go back and rectify that quickly. So I'm going to say interface gig ethernet 0/1/0, and I would say no IPv6 address. And I'm just going to copy this and paste it in here. And then I will up arrow this, and I will change the first nibble of the IPv6 address from 2024 to 2025. And I'm also going to bounce the interface. So I'm going to say shut, and I will also enable it again with the no shut command. I will hit end, and let's just verify the configuration quickly. So I'm going to say show run pipe section root. You can see that I still have got the IPv6 root config, and if I issue the show IPv6 root command, I am still unable to see the default root being implemented in the routing table. So what I would do, I'll go back to global config, and I'm actually going to negate this command, and I'm going to apply it again. Or actually, before I do that, let's just look at the interface status. So I'm going to say do show IPv6 interface brief. And right now, I can't see the IPv6 has been taken under the interface. gig Ethernet 0/1/0. So let's look at the current config again. So do show run section 0/1/0. Okay, I will need to kind of like reinforce the IPv6 address under this interface. So I'm going to say interface gig Ethernet 0/1/0. Let's set the IPv6 address. And I'm going to shut the interface and then enable the interface again. And let's have a look at the running config. And this time we can see this is the configuration under that interface. Next, let's look at the IPv6 routing table. And again, I can't see the default static route, so I'm gonna check if the configuration has been taken again. So I'm gonna say show run pipe section route, and I would need to implement that. So if I issue this command, that should do the trick. So if I go back and just verify this quickly, and finally we can see the default static route has been implemented successfully and as requested. So that concludes step number 6. Now I'm going to jump into step number 7, where we need to configure a floating route for IPv6, and we're going to set the next hop IPv6 address to the ISP2 IPv6 address. So I'm going to go back to global config, and I'm going to say IPv6 route, and I'm going to include ::/0, and I will set the next hop address to 2024:2023::2, and also I'm going to set the metric. So if I question mark that, you can see that we need to set the administrative distance, and we're going to set that to 10 as per request from the playbook. I will hit enter. And then if I hit end, and let's just verify the current configurations for all the static routes that we have configured. So I'm going to say show running -config pipe include route. You can see this is the primary IPv6 static default route, and this is the backup IPv6 static default route with an administrative distance set to 10. So if I reveal the IPv6 route again, you will not be able to see the floating static route that we have just implemented. So what I'm going to do, I'm going to jump into step number 9, where we're going to perform some basic connectivity. We want to make sure that PC1 is able to communicate and talk to PC5, as well as internal server 1 and also the external server. So I will go to my topology, and I'll go to PC5, and from there I would issue the command ping, and I'm going to say ping 2000. Actually, instead of using PC5, excuse me, I'm going to go back to PC1. So I'm going to go to PC1, and from there I'm going to say ping 2024:1001:5. So that proves that there is reachability and connectivity between PC1 and PC5. Let's try to ping PC6. So I'm going to say ping 2024:1001:6. Again, we have reachability and connectivity to PC6. Let's now test connectivity to internal server 1. So I'm going to up arrow this, and I'm going to change the second nibble of the IPv6 address to 1002. And I'm going to include the last nipple of the IPv6 address to 101, and we can reach internal server 1. Let's just up arrow this and try to reach internal server 2. We also have connectivity and reachability. Now, the final test that I want to do is let's check if we can reach the external server or not. So I'm going to say ping 2024 colon 1111 colon 1. And you can see that we are able to reach the external server. And now it's the point where we need to find out which route the traffic is taking. So I'm going to say trace RT or trace route. And I'm going to copy the IPv6 address for the external server. And if we look at the third entry of the output, you can see that it's pointing to the ISP1. So the ISP1 IPv6 address is actually 2025 colon 2024 colon 2. Next, let's jump into step 11, where we are going to simulate a link failure for the primary link, which is interface gig Ethernet 0/1/0 that is connected to the ISP1. So I'm going to do this, and I will issue a continuous ping. So I'm going to say ping -n100, and I'm going to copy this IPv6 address, and I will hit enter. And then what I'm going to do, I'm going to unplug the interface from here, and I'll try to plug it into the ISP1, and I'll go back to PC1. And you can see that we haven't lost any packet. So I'm going to cancel this. And what I will do, I will trace route this. And right now, if you look at the third entry, you can see that the traffic is being rerouted to the second ISP, which is 2024 colon 2023 colon 2. And if I go back to my headquarter router 1, and let's just issue the show IPv6 route, you can see the first entry, that is the floating static route that we have configured, and you can see the administrative distance is set to 10, and the next hop address is set to 2024 colon 2023 colon 2. Okay, so with that being done, we have verified that the floating static route is actually operation as expected. So what I'm going to do next, I'm going to go back to my topology, and I'm going to try to rectify the link. So I'll go back to my topology, and I'll try to delete the link, and I will try to build it again. So I'm going to say Viper, and I'm going to say here, I'm going to set the gig Ethernet 0/1. Then I'm going to connect it to gig Ethernet 0/1. And if I go back to PC1 and up arrow multiple times just to make sure that there is reachability and connectivity to the external server, you can see that we are able to reach it. So I'm going to trace route this. And now we can see that looking at the third entry of the output, you can see that we are using the ISP1 again, which has an IPv6 address of 2025 colon 2024 colon 2, which matches this. And if I were to look at the IPv6 routing table, you can see that the default static route, which is the primary static route that we have configured, is being implemented back into the routing table, as you can see on the screen here. So at this point, we can go ahead and save the configuration, and we have reached the end of the lab. Okay, so that's it, folks, for this video. If you found this video helpful, please don't forget to give it a thumbs up. And if you haven't already, please hit that subscribe button and turn notifications so you never miss our future tutorials and tech insights. If you have any questions, comments, feel free to drop a comment below. I read all your comments, and I'm here to assist you. Remember, consistency and hands-on practice are key to success, so stay curious, stay inspired, and until next time, peace.